All right, hello there. So today we're going to talk about rational functions. So rational functions, remember, are functions that have a fraction. So, rational ratio, a rational expression is something with a fraction. So let's write our title down. So we are in Unit 2, and we're talking about graphs of rational functions. Now, you did this in Algebra 2 as well, so we're just going to review this. We have a little bit of new stuff to add in class later, but for now, let's just review what you know. So let's start off with this example. So let's say we have this equation, y equals 5x plus 2 over x minus 1. So you might remember that you have what are called horizontal and vertical asymptotes. So remember, we've done this a lot in this year. You would never want the bottom of a fraction, the denominator, to be 0. So you would never let x be 1 here. So that starts you off with a good thought of your domain. Your domain is everything but 1. So you want to say from negative infinity to 1, or from 1 to infinity. So there's our domain right there. So that's going to be also tying in with our vertical asymptote. Because we're never going to be touching 1, then we're going to have a vertical asymptote of x equals 1. And so remember, we would graph that on our picture here, x equals 1. So at x equals 1, I would draw a vertical asymptote, and I would never touch that line. Okay? So then we come to where we have a horizontal asymptote. A horizontal asymptote is more of something that you can touch it, but it's more of like what your function goes to as you go towards infinity or negative infinity. So it's like what your function calms down to be. All right, so when I look at this right here, remember there's 3 rules. The first rule is that if your x's match, and these ones do. If the x's match, then you take the leading coefficients. You take like 5 over 1 right here, and 5 over 1 is 5. So that's going to be my horizontal asymptote, y equals 5. But remember the other rules. If the top is smaller than the bottom, like if the bottom was x squared right here, then the x on top would be a smaller degree than the bottom. Then my horizontal asymptote would just automatically be y equals 0. And if for some reason the top was a higher degree than the bottom down here, then we'd have something called a slant asymptote, which we will get into in class. Okay. All right, so y equals 5. So let's draw that on here also. So y equals 5. Ooh, that's pretty high. Oh well. Didn't mean for that to be that high, but that's fine. All right, so we have a couple other things we can find. We can find an x-intercept and a y-intercept at times. So sometimes it doesn't touch the x or the y-axis in some ones, but this one does. So remember, for an x-intercept, if I want an x-intercept, I have to let the y value be equal to 0. And for a y-intercept, I let x be 0. Now letting x be 0 is very simple to do. Basically, I just go to my equation and all these x's are 0, 0. And so all I have left, if these things are gone, I have 2 over negative 1. Well, 2 over negative 1 is negative 2. Now the y-intercept is a little bit more tedious. Remember, the y-intercept is when y equals 0. I'm sorry, the x-intercept is when y equals 0. So when y equals 0, that means my whole equation is equal to 0. So when does a fraction equal 0? Well, you guessed it, when the top is equal to 0, that's when the whole fraction equals 0. So the x-intercept is a little bit annoying. I have to let the numerator equal 0. So in that case, in this problem, that would bring me to 5x plus 2 equaling 0. So if I solve that, I get negative 2 over 5. All right, so we can mark those places on our picture. So I'm going to go ahead and mark negative 2/5, 0. So that would be about right there. I'm going to mark 0, negative 2. That would be about right there. And for the rest of this picture, I'm going to go ahead and look at Desmos. All right, so I do have that graphed here. So let me turn these other ones off. So there is that picture right there. You can see that the x equals 1 was my, right, wait a minute. Yeah, x equals 1, sorry. I got confused for a second. X equals 1 was my vertical asymptote, and then my horizontal asymptote is 5, so it's looking good. And you can also see my intercept right there. See that thing right there? That's at 0.4, which is 2/5. And this one down here is 0, negative 2. So you can zoom out and you can see that, the function, as you go to the infinity on the right or the left, it approaches y equals 5. Okay, so we're just going to kind of fill the rest of that in there on our picture. All right, so it's not going to be perfect, but I do have these 2 points down here, so I'm going to go through those, and it kind of comes up towards my asymptote, and this one loops around there. So not looking for a perfect graph unless we're doing this on MathSpace, but all right, so a few more examples of this. So my next example is, oh, wait a minute, I forgot to mention the range here. My range, remember I'm not touching my horizontal asymptote in this picture, so my range is going to be from negative infinity to, let's see, I'm not touching 5, so 5, and from 5 to infinity. That's my height. All right, so this one right here, what we want to do is 6x squared plus 5. And the bottom, the denominator is 3x squared minus 10x minus 8. Now remember, if I can factor, I should. So the denominator does factor. So 3x and x, what multiplies to 8? I think we'll try 4 and 2. If I put a 4 here and a 2 there, I get 12x and 2x, which I can make a negative 10 if this is negative 12 plus 2. So make that negative, make that positive, and it works out to negative 8 again. The numerator does not factor. 6x squared plus 5 doesn't factor, so we're all set. Okay, so let's begin. So my domain is everything except, let's see, my vertical asymptotes. So my vertical asymptotes are going to be at negative 2/3 because that's the 0 of this guy right here. And then my other vertical asymptote is going to be at 4 because that's the 0 of this guy, of that guy right there. Okay, so that also leads me to my domain. My domain has 2 problems. All right, so my domain can't be negative 2/3, can't be 4. So it's going to be a little bit messy. So think of a number line that you don't want to touch negative 2/3 and you don't want to touch 4. So you can have this area, and this area. So my domain is going to be from negative infinity to negative 2/3, or from negative 2/3 to 4, or from 4 to infinity. So you probably didn't really have to list ones like this out last year, but it's going to be multiple choice on your MathSpace, so it won't be too hard to figure out. All right, my horizontal asymptote. Well, in this case, I have the same situation as last time. I do have matching x squareds, so my horizontal asymptote is going to be 6/3, so in this case 2. All right, and we'll take a look at our graph and see if the y value is avoiding 2, just to be sure, because it's more complicated. So if I was going to start drawing this graph, I would draw my asymptotes. X equals negative 2/3, so right about here. And then x equals 4. So this graph is more complicated because it has 2 x vertical asymptotes, and then y equals 2, so across here. All right, and let's real quick go and do our x and y intercepts. So my x-intercept and my y-intercepts. All right, so my x-intercept, remember, is when y equals 0. And then my y-intercept is when x equals 0. So when x equals 0, that's easy to do. I'm just going to pretend all these x's are gone because they're all zeros. So there's my 2 numbers, 5 over negative 8. So I'm going to get negative 5/8. So 0, negative 5/8 is right down here. Okay, and then my x-intercept. My x-intercept is when the numerator equals 0. All right, so when the numerator equals 0, because remember that's when the y value equals 0, so it's when the top equals 0. And so what I get is this equation right here, 6x squared plus 5 equal to 0. Well, look at that. If I try to solve it, I will get x squared equals negative 5 over 6, and I have to take the square root, but I can't do the square root of a negative without getting imaginaries. So also think about this problem right here. When would something plus 5 ever equal 0 if this something back here could never be negative because x is being squared? So this is never happening. I'm not going to get an x-intercept. Okay, so there is no x-intercept. So it's not going to touch the x-axis. All right, so let's go look at our picture. All right, and there's that creepy, weird graph right there. It's kind of curving on the right side, curving on the left side, and kind of like a parabola in the middle. So we're just going to sketch that. No big deal. Don't have to, what's it called? Sorry about that. Don't have to do much with it. So this one is kind of coming up here, going off like that. This guy is coming over here. And this one over there, see, kind of went a little too low there, but just the main idea. All right, just a couple more graphs to talk about, and we won't graph these, but maybe we'll just look at them. We'll just like do all the pieces for them. Let's start with this one. Let's do y equals 3 over 2x plus 7. All right, so my horizontal asymptote and vertical asymptote. My vertical asymptote is whenever the denominator equals 0. So I get 2x plus 7. When does that equal 0? If I solve that, I get negative 7 over 2. So my vertical asymptote is negative 7 over 2. My horizontal asymptote, and I should have said there, I should have said x equals. My horizontal asymptote is y equals, well, let's take a look. The top part has no x at all right here, and this one does have an x. So the top is smaller degree than the bottom. So automatically, horizontal asymptote is 0. All right. So my domain would be everything except negative 7 over 2. My range is going to be everything except 0. All right, so just like we wrote in the first example. And let's do the x and y intercepts. So x-intercept is when the y value equals 0. Y-intercept is when the x value equals 0. Oopsie. All right, so let's check it out. When when x equals 0, that's easy to do. I just let this part be 0, so I get 3/7. So that's a nice easy answer. But let's see, we're going to let y be 0. So that means I'm going to let y equal 0 here. Well, how can 3 ever equal 0? It's not going to. All right, and the bottom can't be 0 because that's my vertical asymptote. So this thing is actually never going to be 0. So there is no x-intercept. And that also happens a lot when you have this right here. Whenever your horizontal asymptote is y equals 0, then frequently you're not going to touch the x-axis because that's when y equals 0. So your two asymptotes are going to look like this, y equals 0, and then x equal negative 3.5, 7 over 2. So this is what they look like, and then the graph comes in between there. So we'll take a look at it. 3 over 2x plus 7. Oh, come on, you silly thing. Oh my goodness, I just had this open. All right, so let's turn these other guys off, and there's that graph right there. So notice it's not touching the x-axis. Notice my y-intercept right there. I can't get it to go, but it's looks like 3 over 7 right there. Oh, there it is. Okay. Okay. All right, so let's go back and do our last example. All right, so let's see. Last example is this, y equals 2x over x squared minus 9. All right, now this factors 2x over and then x plus 3, x minus 3. So I'm going to have two vertical asymptotes. One is at x equals 3, one is at negative 3. My horizontal asymptote is going to be y equals 0 because the top has an x and the bottom has an x squared. And let's see, my x-intercept and my y-intercept. If I let x be 0, because let's see, let x be 0 for my y-intercept, let y be 0 for my x-intercept. If I let x be 0, look what happens. I get 0 on top, 0 down there over minus 9. So 0 over negative 9 is just 0. So that's going to be a 0 right there. Well, that's the origin. The origin is an x-intercept and a y-intercept. So we have found both of them. All right. So this thing is definitely touching right here at the origin. My asymptotes are 3 and negative 3. So there's 3, negative 3, there's positive 3. All right, my horizontal asymptote is 0. All right, so our graph should be around this. All right, so let's go take a look. My domain, by the way, is basically, remember, everything except negative 3 and positive 3. So again, you're going to want to name these three areas like we did in the other example. Now my range, you might think it's everything but y equals 0 right here. But let me show you what happens in this graph. So when I go to look at this picture, and I hope, oh my gosh, it closed out again. How annoying. When you go to look at this picture, look at that middle section. See how that middle section comes through and it touches the y-axis? So that middle section like covers all the y values up and down forever. So this range is all real numbers. So if somebody ever asks you that, you're like, oh, well, the middle section takes over and covers everywhere. If that middle section wasn't there, I'd say my range was everything but 0, but it's all real numbers. Okay, And that is it. I'll talk to you later.